I'm back, and so now we want to talk about how is the rock cycle related to other cycles in the Earth system. And so the first one is going to be called the tectonic cycle, which is plate tectonics. So the idea that when material comes up from the asthenosphere at a mid-ocean ridge, that forms rocks. Okay, then those rocks are on a moving plate, and then those plates could be subducted underneath the continent, and then those materials could melt, and then they could come back up again to make volcanic mountains. Then we also found that plates could be pushed together to make mountains, so that would be another type of rock in the rock cycle. And then we also found that plates could slide past each other, and in doing so that would crush the rocks in between, and so that would make a type of metamorphic rock. So all of your different kinds of rocks, whether it be igneous, metamorphic, or sedimentary, are tied to plate tectonics and the tectonic cycle. Okay, another kind of cycle is the hydrological cycle. So this is where does water come from, and then where does water go. So let's start with volcanoes. So when volcanoes erupt, they give off tremendous amounts of carbon dioxide and water in the form of steam. So actually most of the stuff that comes out of a volcano is just steam, plain old water. Okay, now what does the water do when it gets into the atmosphere? So it starts to cool off, and then it forms clouds, and then it rains liquid water back onto the earth. Now it could be rained onto the oceans, or it could be rained onto the continents. If it's rained onto the continents, it could flow on the surface of the continent in the form of rivers, and then go into lakes, and then eventually end up in oceans. Or that water could sink into the ground and could become part of groundwater, and then that groundwater, it could come back to the surface as a spring, or it might just flow directly into a lake, which of course then the lake is going to drain into the ocean. You also have evaporation. So the oceans, when they get heated up, they could evaporate water, which then would go up into the clouds, or you could have water could evaporate off the ground, or water could be taken in by plants, and then those plants could transpire, which means that they give off water, and then that water could go into the clouds. And then finally, one more path would be the water in the oceans could get into the rocks on the ocean floor, and then those rocks could be subducted underneath the continent, and then the plates would melt, and then that water would be released, and then the water would come back out the volcanoes again. So it's very complicated, and you have different routes that the water can take. So how is the hydrological cycle going to be related to the rock cycle? So you could have, for example, we know that rain acts as an agent of weathering. Okay, we know that once the sediments get into a river, the river's made of water, and then that is an agent of weathering and transport. Okay, we also know that groundwater, when it's percolating through the ground, it can dissolve calcite in limestone, and it can leave caves. Okay, another thing is that rocks that contain water are going to be more likely to melt and then come back out of volcanoes as igneous rocks. We also found that water was important in metamorphism. So water is important in all of these different processes in the rock cycle. Okay, now let's talk about the carbon cycle. So where does carbon dioxide come from, and then where does carbon dioxide go? So it's very similar to the hydrological cycle. So let's assume that carbon dioxide comes out of volcanoes along with the water. So it goes into the air, and then it can be washed out of the air by rain. So as it rains, it will collect some of that carbon dioxide. Now that carbon dioxide could go into the oceans, combine with the ocean water to make limestone. Okay, then the limestone could be on a plate that is being subducted, and then the plate melts, and then the carbon dioxide comes back out the volcano again. Or you could have the carbon dioxide could go into the earth, into the continent, and it could seep through the ground, and it would be acidic because that carbon dioxide will mix with water, with rainwater, and it will make an acidic material, a carbonic acid, which can erode caves. And so that's how you make a cave, is as this acidic acid goes through the limestone, it's going to start to dissolve the calcium carbonate, and then you're left with caves. Okay, what's some other places where the carbon dioxide can go? Well, carbon dioxide can also be absorbed by green plants. So green plants will take in carbon dioxide, and then it will turn it into oxygen through the process of photosynthesis. Okay, another place where you get carbon dioxide is animals. So animals that take in food, and then they convert those carbohydrates and proteins and things like that. As they break down that stuff, they consume oxygen, and they give off carbon dioxide. So then that can go back into the atmosphere. Okay, then you also have what humans can do. So humans, with our cars and with our power plants, they also produce carbon dioxide, which goes into the atmosphere. So later in the course, we're going to talk about how this carbon cycle causes the greenhouse effect, which can be warming up the climate. So it all depends on how much carbon dioxide is in the air. If there's too much carbon dioxide in the air, it's going to act like a greenhouse gas, and then the climate is going to warm up. If, on the other hand, there's not enough carbon dioxide in the atmosphere, then the planet can actually cool down. So we'll talk more about that in a future lesson. Okay, let's take one more break, and when we come back, let's take a quiz over this lesson.